Alright, so this first video is an intro to multiplying matrices. In 3-6 we multiplied a matrix, just one matrix, by a scalar, like a constant. But in this video we're going to be multiplying a matrix by a matrix. So with addition and subtraction, remember the only way that you could add or subtract them together was if their dimensions were exactly the same. With multiplying matrices, there is a different requirement that you have to meet. So what it is with multiplying matrices, you can multiply two matrices together if and only if, so let's take a look at this. So say we've got matrix A, remember we use capital letters, and say matrix A is an M by R matrix. So that means M rows, R columns, and we wanted to multiply it by matrix B. Okay, so we're taking matrix A, we're trying to multiply it by matrix B. And then let's say matrix B is an R by T matrix. This is the only way that you can multiply them together, is if the number of columns in this matrix are the same as the number of rows in this matrix. So what happens is these two right here have to be the same. Okay, if these two are not the same, then you cannot multiply them together. Okay, so the requirement is the number of columns in A has to equal the number of rows in B. Okay, if that is not held, then you cannot multiply them together. And what ends up happening is you get a new matrix, and that matrix we just call capital A, capital B. The new matrix is this as a dimension. So the new matrix is going to be an M by T matrix. So the way that works is these inside dimensions have to match up. If they do, you can multiply them, and the new dimensions are the outside two dimensions. So let's practice that. So determine whether you can multiply these together. If so, state the dimensions. So A is a 3 by 4, B is a 4 by 2. Their middle two numbers do match up. So yes, the product would be defined. Yes, you are allowed to multiply them together. And the new dimensions would be the outside two numbers. So it forms a 3 by 2 matrix when you multiply them together. 3 rows from the first, 3 columns, 2 columns from the second. So then this one, we want to see if it's defined. 2 columns in A, 4 rows in B. Those do not match up. So no, it's not defined, which means I can't state what the dimensions would be. Okay, so let's learn how to actually do this. So multiplying matrices, the element in the mth row and rth column of matrix AB. So I know this all sounds very generic and weird. So what we do is we organize the first matrix by rows like this, and we organize the second matrix by columns like this. Okay, so M row of matrix AB, rth column of matrix AB is the sum of the products. So this is very crazy as we're walking through, but the corresponding elements in row M of matrix A and column R of matrix B. So the important part is that the first matrix you're going by rows, and the second matrix you're going by columns. All right, so here is how this is going to work. So first of all, this is a 2 by 2 matrix, 2 rows, 2 columns. This is a 2 by 2 matrix, again, 2 rows, 2 columns. Since these numbers match up, I know I am allowed to multiply them together, and the new matrix is going to have these dimensions. So RS, the new matrix, we know is going to be a 2 by 2 matrix. So here's what we do. We're going to set up kind of an overly large matrix because we got a lot of work to do in here. So it's going to have 2 rows and 2 columns. So I'm going to have 4 elements total. So when I'm looking for row M, column R of this new matrix, says it's the sum of the products of the corresponding elements in row M of matrix A and column R of matrix B. So I will explain that. So this is the first row, first column. So I look in row 1 of the first matrix and column 1 of the second matrix. So again, this is, and let's write here, this is row 1, column 1. This is row 1, column 2. This is row 2, column 1. And this is row 2, column 2. So this one right here means I look in row 1 right here. And this one means I'm using column 1. So let's read this one more time. The sum of the products of corresponding elements. So here's how this works. The first element here and the first element here, I multiply them together. So I multiply 3 times -2. And then it's the sum. So then I add to that the product of the next corresponding elements, 2 times 1. Okay, so the sum of the products of the corresponding elements in row 1 and column 1 for this specific one. And we'll simplify that up in a second. Now, row 1, column 2 means I use these elements in row 1, and now I'm going to use these elements in column 2. So I look at the corresponding elements, take the product, add the product together. So I do 3 times 1, and then add that to 2 times -1. It's going to seem crazy right now. I promise it'll get easier as we get going. Now we're in row 2, column 1. So I use row 2 in the first matrix, column 1 in the second matrix. And I'm going to take the sum of the products of the corresponding elements. So -1 lines up with -2, so I take the product of those. And then add that to 0 times 1. Okay, finally, row 2, column 2. So I use row 2 in the first matrix and column 2 in the second matrix. Take the products of the corresponding elements, add them together. -1 times +1 plus 0 times -1. Okay, so now I'm just going to simplify these up, and I'm going to have my new matrix. So 3 times -2 is -6, plus 2 times 1 is 2. 3 times 1 is 3, plus 2 times -1 is -2. -1 times -2 is +2, plus 0 times 1 is 0. -1 times +1 is -1, plus 0 times -1. Okay, finally add these up. -6 and +2 leaves me with -4. 3 and -2 is 1. 2 and 0. -1 and 0. So that is my brand new matrix. All right, so we've got that answer. Let's move down to the next one. We've got a bit of a story problem. It says 3 teams competed in the final round of the chess club championships. For each win, a team was awarded 3 points, and for each draw, a team received 1 point. Which team won the tournament? So if you look at this, this is a nice matrix right here. It's got wins in the first column, draws in the second column. So if you look at the way these matrices are supposed to be organized, we end up multiplying by corresponding these rows with these columns. Now notice the wins and draws are in columns. So in the multiplying order, this needs to be set up as the second matrix because the second matrix goes by columns. So we're going to organize this. Those are the number of wins. This is the number of draws. Okay, so then we have this second matrix. It says for each win, a team was awarded 3 points, and for each draw, a team received 1 point. Which actually, now that I'm looking at it, since we're trying to see which team won the tournament, we actually should keep it organized in rows because we want the blue team, the red team, the green team. So what we're going to do then is we're going to multiply it by a matrix that will multiply each of these by 3 and each of these by 1. Okay, so we want to take, for the blue team, 5 wins and 4 draws, and we want to multiply it by this little matrix, which gives you 3 points for each win and 1 point for each draw. So I apologize for saying this should be the first, second matrix should actually be the first. So I am going to line each one up, so it's going to look like this. This is a 3 by 2 matrix. This is a 2 by 1 matrix. So since these middle 2 dimensions line up, my new matrix will be a 3 by 1. So I'm going to have 3 rows and just a single column. So what this is going to give me, this will give me the blue team's total score, the red team, and the green team's total score. So I multiply 5 wins for the blue team times 3 points per win. And then add to that 4 draws for the blue team times 1 point per draw. Okay, so when I add those up in the next step, that'll give me the blue team's total score. Then for the red team, I'm multiplying 6 wins times 3 points each. And then plus 3 draws for 1 point each. And finally for the green team score, here's the green team's stats right here. 4 wins times 3 points each, plus 5 draws for 1 point each. Okay, so let's simplify this up. Blue team got 15 points for wins, 4 points for draws, that's 19 total points. Red team got 18 points for wins, 3 points for draws, that's 21 total points. And the green team got 12 points for wins, 5 points for draws, that's 17 total points. So we end up with our high score here is 21. So which team won the tournament? That would be the red team. So basically what we're doing with this next video for 3-6 is testing out to see whether the multiplicative properties, the ones that work for, normal numbers and stuff, to see whether they work for matrices as well. So if you look at this one, we've got K and L, and we're trying to find K times L as well as L times K. So what we're testing here is the commutative property to see if multiplying them in a different order would make a difference. Okay, so first, when we're setting up multiplication, we want to set up the dimensions. So this one has 2 rows and 3 columns. And this one has 3 rows and 2 columns. Okay, so K times L. K times L would be a 2 by 3 times a 3 by 2. So the middle dimensions match up, which means that we're able to multiply them and we'll get a 2 by 2 as a result. Okay, so we're going to get everything all set up to multiply out together, and we know we're going to get a 2 by 2, so 2 rows, 2 columns. Okay, so we always do rows for the matrix on the left and columns for the matrix on the right. So for row 1, column 1, we are lining up row 1 here with column 1 here, and remember we multiply each entry together and then add them together. So -3 times +1 gives me -3, plus 2 times 4 gives me 6, plus 2 times 0 gives me 0. Okay, then I move over here. I am still in row 1, but now I am in column 2. So I still use row 1 over here, but then I am going to pair it up with column 2 this time. So I pair up -3 times -2, that gives me 6. 2 times 3 also gives me 6. 2 times -1 gives me -2. Okay, move down to the next row. Now I'm in row 2. I'm back in column 1. So I'm going to use row 2 right here times column 1, match them up and multiply them. -1 times +1 is -1. -2 times +4 is -8. 0 times 0 is 0. Then I move to my last spot. This is row 2. Now I'm back in column 2. So I'm going to use row 2 here in K and column 2 here in L. -1 times -2 is +2. -2 times +3 is -6, and 0 times -1 is 0. Okay, so I'm going to clean all this up. -3 plus +6 plus 0 gives me a +3. Next column, 6 and 6 is 12, -2 goes back to 10, -1, -8 is -9, +2, -6 is -4. So that is the matrix that I get for K times L. All right, so now let's do L times K. So I'm going to rewrite these just so you can see them going by rows and columns since they're going to switch. So here's L. Remember, now that we're putting L first, we're going to organize L by rows instead of by columns. So I'm just going to rewrite them. Okay, and then here is L times K. So here's L, we're going to organize it in rows, and here's K, we're going to organize it in columns. So just so we know what we're expecting, L is a 3 by 2, K is a 2 by 3, so we're allowed to multiply them together since their middle dimensions match up, and the new matrix that we get is going to be a 3 by 3. Okay, so LK is going to be a 3 by 3 matrix, so we can set that up. So before we even finish this problem, I think you can see that KL and LK are not the same. We're going to go through just so we can get some multiplying practice, but a 2 by 2 matrix couldn't possibly end up the same as a 3 by 3 matrix. Let's set all this up though. So 3 by 3, we are going to have 3 rows, 3 columns. Okay, so this one is a bigger problem than we've dealt with. So here we have row 1, column 1. This is 1, 2, 1, 3. Then we move down to row 2. So this is row 2, column 1, 2, 2, 2, 3. And then finally we're in row 3, column 1, 3, 2, 3, 3. So row 1, column 1, we're going to use row 1 here, column 1 here, add them up from the products. So 1 times negative 3, add that to negative 2 times negative 1. Next, row 1, column 2, 1 times 2, negative 2 times negative 2. Okay, and then to finish off this row, we're still in row 1, we're moving to column 3 for this position. 1 times 2 is 2, plus negative 2 times 0 is 0. Alright, so that's the end of row 1. Now we move down to row 2 and then go across the columns. So 2, 1, we use row 2, column 1. 4 times negative 3 is negative 12, plus 3 times negative 1 is negative 3. Row 2, column 2, 4 times 2 is 8. 3 times negative 2 is negative 6. Row 2, column 3, 4 times 2 is 8. 3 times 0 is 0. Okay, last row, we're in the third row here, and again, we're going to move across the columns. So 0 times negative 3 is 0. Negative 1 times negative 1 is positive 1. Row 3, column 2, 0 times 2 is 0. Negative 1 times negative 2 is positive 2. And finally, 3, 3. 0 times 2 is 0. Negative 1 times 0 is 0. Okay, so to get our new matrix, we're going to add all these things together. Negative 3 plus 2 is negative 1. 2 plus 4, 2 plus 0. Negative 12 plus negative 3, 8 and negative 6, 8 and 0, 0 and 1, 0 and 2, 0 and 0. So that is my 3 by 3 matrix. So in case we can't tell, we are going to make ourselves a little note that says that multiplicative commutativity does not hold. So these are some big fancy words here. That just means if you multiply two things in a different order, they're not necessarily going to come out the same. Now there may be exceptions, but as a rule in general, commutativity for multiplication does not hold. We just learned that. Okay, so now with example 5, what we're going to be testing out is the distributive property. Like if we distribute this A to both of these matrices, are we going to get the same answer or not? So when we are testing this one, order of operations holds, so we're going to add B plus C first. So these are all 2 by 2 matrices. That means we're allowed to add them and multiply them. So add B plus C means we're going to add the corresponding entries. So we add 1 plus negative 3, and we get negative 2. Add 0 plus 1. Okay, down here, 3 plus negative 1, and negative 2 plus 0. Okay, so that is B plus C. Now, to get A times B plus C, we are going to line these up like multiplication. So first A, so negative 1, 2, 2, 1, and then times what we just got, B plus C. Okay, so we're going to multiply these two matrices together. Again, they are both 2 by 2s, which means I'm allowed to multiply them. These middle match, and so the outside will be my new dimension. So I know my new dimension is going to be a 2 by 2. Okay, so let's label all these. This is row 1, column 1, row 1, column 2, row 2, column 1, and row 2, column 2. Okay, so here's what I'm multiplying over here. So row 1, column 1, row 1, column 1. Negative 1 times negative 2 is positive 2. 2 times 2 is 4. Okay, next, row 1, column 2. Negative 1 times 1 is negative 1. 2 times negative 2 is negative 4. Bottom left, we've got row 2 back to column 1. 2 times negative 2 is negative 4, plus 1 times 2 is 2. And row 2, column 2. 2 times 1 is 2. 1 times negative 2 is negative 2. Okay, so I'm going to combine these up. 2 and 4 gives me 6. Negative 1, negative 4. Negative 4 and positive 2. And positive 2 and negative 2. So that is what I get if I add inside the parentheses first, then multiply by the a. Okay, let's see what we get if we multiply first, then add together. So let's start with a times b. So here's a, and I want to multiply it by b. Okay, so we've done enough of this matrix multiplication. I think we can do it fairly quickly. So this first spot is going to be the first row, first column. So I can use first row, first column. So negative 1 times positive 1, 2 times 3. Okay, now I'm going to move over to the first row, second column. So I use first row, second column. Negative 1 times 0, 2 times negative 2. Okay, now I move down here. I'm in the second row, first column. So 2 times 1, 1 times 3. And then finally, second row, second column. So 2 times 0, 1 times negative 2. Okay, so let's clean this up. Get our first matrix, AB. Negative 1 and positive 6, 0 and negative 4, 2 and 3, and 0 and negative 2. Okay, so that's AB. Now let's get AC. Okay, so again, here's A. And I will copy down C, negative 3, 1, negative 1, 0. Okay, so again, I know I'm going to get a 2 by 2 matrix, and we can go through this fairly quickly. So this first spot is row 1, column 1. So negative 1 times negative 3, 2 times negative 1. Next, row 1, column 2. Negative 1 times positive 1, 2 times 0. And down here, row 2, column 1, 2 times negative 3, 1 times negative 1. And row 2, column 2, 2 times 1, 1 times 0. Okay, so combine these up. Add each item together. 3 minus 2, negative 1 and 0, negative 6 and negative 1, and 2 and 0. Okay, so this is AB right here, this is AC right here. Now we want AB plus AC. So we're going to take the two pieces we got, add the corresponding elements together. Okay, so 5 and 1 gives us 6 in the first row, first column. Negative 4 and negative 1 gives us negative 5 in the first row, second column. Down here, 5 and negative 7 leaves me with negative 2. And finally, negative 2 and positive 2 leaves me with 0. So I end up with the exact same thing for both of these. So the distributive property does hold. Okay, so we've got one property that does hold, one property does not. We've got one last problem. Actually, I'm sorry, we don't have one last problem. We just have the properties that we're going to write down. So the ones that we just mentioned, we've got the commutative property, we've got the distributive property. I'm just going to write down a summary here. So Here's what else we have. We've got the associative property that also holds. So the associative property looks like this. So we did not prove that one, but you could if you want to. And then we have the left distributive property, which is what we just proved. And then we actually also have the right distributive property, which would look like this. Because remember, left and right multiplication are different since the commutative property doesn't hold. But right distribution holds just as much as left distribution. So we've got those three properties.